All right, today we are going to learn how to solve permutations and how to solve combinations. In our last lesson, we talked about the difference between the two, and now we're going to, now that we know the difference, actually solve them. So let's start with permutations. As a quick reminder, a permutation is a counting method where the order matters. So we are going to solve these by looking at how many choices and spaces we have. So permutations are written with a large capital P for permutation. And then on the left side, we have a little n as a subscript, and on the right side, we have a little r as a subscript. And the n represents how many choices we have, and the r represents how many spaces we have to put those choices in. So I think once we do an example, this will make a little more sense. The first example says judges at a marching band competition are awarding prizes to the first, second, third, and fourth place finishers. The competition has 12 marching bands. How many different ways can the first, second, third, and fourth place prizes be awarded? All right, so obviously we know this is a permutation. The order matters because we're giving a first place and a second place, and I care if I get first place or fourth place. That would be a difference, so the order matters. All right, so let's think about it this way. We have a first place, a second place, a third place, and a fourth place. So if there's 12 bands in the competition, all right, that's how many choices we have. So we're going to write this with a capital P, and my subscript on the left side is going to be a 12 because there are 12 choices of bands. And then there are 4 spaces to put them in, okay? So how many bands could win first place? Well, there are 12 bands that could win first place. How many bands could win second place? Well, if one band has already won first place, then there's only 11 options for second place, 10 options for third place, and 9 options for fourth place, because once we get to fourth place, obviously one band has already won first, one has won second, one has won third, so that only leaves 9 bands left as the option for fourth place. Now, to figure out how many different ways these can be awarded, which is what the question is asking, all I have to do is multiply these 4 numbers. All right, now obviously for this lesson and the homework, you are going to want your calculator because that's going to make this go a whole lot faster. So I'm going to type in 12 times 11 times 10 times 9, and that would give me 11,880 different ways. This is a word problem, so don't forget that label. And typically the question at the end tells you what your label will be. It asks how many different ways. So my answer is 11,880 different ways. Wow. Okay. Hopefully you're feeling very grateful to have this new shortcut because there is no way that we want to have to list out over 11,000 ways. That would be crazy. Okay. But notice here in this permutation, since there were 12 choices, we started with the number 12, and since there were 4 spaces that they could win, we multiplied 4 numbers out. Let's do a couple more examples. You have 5 new books you want to read. In how many different orders can you read the books? Okay, well, because it tells you right there, we're looking for different orders, we know this is a permutation. So we put a big capital P. All right, how many choices do I have? Well, you have 5 new books, so there are 5 choices. And you're going to read all of these books, so there's actually 5 spaces as well, since you're going to read them all. So, how many books could you read first? Well, you have 5 options to read first. But once you have read a book, then for your second book, you only have 4 options. Now, because there are 5 books we're going to read, we have 5 spaces, and if it helps you, you can draw out those 5 spaces. You don't have to, but you can. So your third book, you have 3 options. Your fourth book, you have 2 options. And your last book, there's only 1 option left. So to solve this permutation, I am going to multiply 5 times 4 times 3 times 2 times 1, and that gives me 120 different orders that I could read these books in. Let's do another one. You have 7 posters to hang in your room. You want to put 1 poster on each wall. How many ways can you arrange the posters? And then it says, note, assume your room has 4 walls. All right, well, the order matters, so this is a permutation. The first question is, how many choices do you have? Well, you have 7 posters, so you have 7 choices. And spaces, well, it says you have 4 walls in your room, so there's 4 spaces. All right, so if it helps you, you can write out those 4 spaces. How many options do you have for the first wall? Well, you have 7 posters as your choice for the first wall. Your second wall, you'd have 6 choices. Third wall, you'd have 5 choices. And your fourth wall, you'd have 4 choices. So to figure out how many ways, I'm going to multiply 7 times 6 times 5 times 4, which gives me 840 different ways that I could arrange those 7 posters on my 4 walls. So hopefully you're seeing this shortcut makes solving these problems a whole lot easier, even when we're dealing with big numbers. Why don't you pause the video right now and try number 3. As soon as you're ready to check your answer, press play again. All right, so in this problem, we had 10 choices and 3 spaces since we were awarding first, second, and third place. So I multiplied 10 times 9 times 8 to give me 720 different ways that these prizes could be awarded. All right, now, the next thing we're gonna look at is something called a factorial. What is a factorial? It is a permutation with the same number of choices as spaces, or spaces as choices. We already solved one of these. Number 1 on the last page, where it asked you how many different orders could you read 5 books. That was, we could also call that a factorial because you had 5 books and 5 spaces since you were reading all of them. So the choices and the spaces were the same. One of the ways that we can write a factorial is with the number and an exclamation point. Now, I know this is kind of weird because we're used to seeing exclamation points in English class, and when we see them in English class, it means that we say that really excited. So you might think that number 1, we would give a big yell for 2. That's not really how we read this. We would read that as 2 factorial. The exclamation point tells you that basically you are multiplying out as many spaces as that number is. Let me do a couple examples for you. 2 factorial would be 2 times 1, which is 2. 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. Now, 0 factorial is kind of one of the weird ones. We would like to think that 0 factorial is 0. It's actually 1. You don't need to worry about that too much, other than if you see 0 factorial, you just need to know that it's 1 because in order to solve more complicated problems, 0 factorial comes out as 1. All right. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Because it's the number 7, we're going to have 7 spaces that we multiply it out. Now, I'm going to need my calculator for this one to go faster. This would be 5,040. 3 factorial would be 3 times 2 times 1, so that would be 6. 9 factorial is going to be kind of long because it's going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And again, you could type that into your calculator. And that one comes out to be 362,880. All right, so hopefully this gives you enough of an idea what a factorial is. We're going to come back to this in just a moment. In the last section on this page, we're going to solve a couple permutations that are not part of word problems. Normally in our lessons, we do non-word problems and then we lead into word problems, but with the permutations, it's actually a little bit easier to think about the word problems. But we can solve it even if we don't know the context for the problem. So for example, number 1, we know there are 6 choices and we know there are 2 spaces. Now, we have no idea what those 6 choices represent or what those 2 spaces represent, but that's okay. We can still figure out the number of permutations. So number 1 would be 6 times 5, which is 30. Again, the first number tells you what you start with, and the second number tells you the number of spaces, tells me how many numbers you're going to be multiplying, how many spaces you have. Number 2 would be 8 times 7 times 6. Again, there are 3 spaces, so we're going to multiply 3 numbers. So 8 times 7 times 6 would give me 336. Number 3, I have 5 choices and 5 spaces, so this is also what we call a factorial, like we just looked at above. So I'm going to do 5 times 4 times 3 times 2 times 1. That's 120. Why don't you pause the video real quick and try 4, 5, and 6. When you're ready to check your answers, press play again. All right, go ahead and check your answers with mine. I want to look real quickly at 3 and 6 because hopefully what you noticed is that 3 and 6 actually both came out to be the same answer, even though they're not the same exact problem. Number 3 was a permutation of 5 choose 5. 6 was a permutation of 5 choose 4. So how did they come out the same? Well, hopefully you noticed that that last number is a 1. And we know that when we multiply something by 1, it doesn't change the value. Let's think about it in the context of a problem. Let's say we are running a race with 5 people. If I say in the first example that I'm going to, for my 5 people, give out places 1, 2, 3, 4, 5, well then that would be a problem that could be represented like number 3. But do you see on number 6, if I say I have 5 runners in my race and I'm going to give 1st, 2nd, 3rd, and 4th place, well, even though I'm not giving 5th place, there's still only one person who could get 5th place. So it's not going to change the number of options. And so just so you notice there that those actually do come out the same because that last number would be 1. All right, we're going to now turn the page and move on to solving combinations. Let's start with a quick review of what a combination is. It's a selection of objects where the order in which the objects are chosen does not matter. So what's the difference? Well, we've talked about this a couple of times now. A permutation is when the order matters, and a combination is when the order does not matter. So if you need to pause the video real quick to write that down, you can. To find the number of combinations of n objects taken r at a time, so just like with permutations, we're going to talk about the choices and the spaces, but this time we have to get rid of those repeats. Since the order doesn't matter, we need to divide out the repeats. Think back to the pizza topping problem where we talked about how ordering a pepperoni and mushroom pizza is the same as a mushroom and pepperoni. And so instead of counting that twice, I only want to count that once. Or when we were talking about the groups of songs, we said song 1, 2, 3 is the same as 3, 2, 1 or 2, 1, 3 or 3, 1, 2. All of those are the same group. And so we only want to count them once. And so what we're going to do is divide the number of permutations of n objects taken r at a time divided by the number of spaces factorial, or r factorial. Let's look at an example. The manager of an accounting department wants to form a 3-person advisory committee from the 10 employees in the department. How many different groups can the manager form? Okay, so notice that the order here doesn't matter. He's not ranking his employees. He is simply making a group of 3 from his 10 employees. So this would be a combination. So we use a big C this time to represent a combination. There are 10 choices because there are 10 employees. He's forming a 3-person committee, so there are 3 spaces. So to solve this, we are going to find the permutation of 10 choose 3, but we then need to divide out the repeats because, for example, let's say my committee is Susie, Jack, and Ashley. Well, if I put Jack, Ashley, Susie, that's still the same committee, so I only want to count that once. So I'm going to divide by 3 factorial, the number of spaces factorial. So let's write this out. The permutation of 10 choose 3 would be 10 times 9 times 8. 3 factorial is 3 times 2 times 1. Now, you have 2 choices. You could either multiply across the top and then multiply across the bottom and then divide or simplify, and that would be one way that would work. Or you can actually simplify before you multiply, just like we often do with fractions. And I will tell you that every single time you will be able to get your denominator to be 1. And so a lot of times I think simplifying first is helpful because you're dealing with smaller numbers. Okay, so I know that 3 goes into 3 once and into 9 3 times. And I know that 2 goes into 2 once and into 8 4 times. Now maybe what you're thinking is, well, couldn't you have put 2 into 10? Yeah, you could have. There's more than one way to simplify this and you will still get the same answer. So notice along the bottom here now I have 1, which is nice because I really then just have to focus on the numerator, which is 10 times 3 times 4, and that's going to be 120. So the correct answer is there are 120 different groups that the manager could form. All you have to write is 120 different groups. Let's try another one. We'll do a couple here that aren't word problems, and then we'll go into some word problems. So, number 1, we have the combination of 6 choose 3. So this is going to be the permutation of 6 choose 3 over 3 factorial. So the permutation of 6 choose 3 is 6 times 5 times 4. The 3 factorial is 3 times 2 times 1. Now, I have a couple options for cross simplifying here. I could say 3 goes into 3 once and into 6 2 times. 2 goes into 2 once, and then I can either put that 2 into the 2 or into the 4. It doesn't matter either way. I'll put it into the 4, and so I end up with 2 times 5 times 2, which is 20. Let's try another one. Number 2, the combinations of 8 choose 5. So this would be the permutation of 8 choose 5 over 5 factorial. So this is 8 times 7 times 6 times 5 times 4. Again, I'm multiplying 5 spaces out. On the bottom, I have 5 times 4 times 3 times 2 times 1. That's 5 factorial. All right, now when I go to simplify, I'm going to first start by saying, well, 5 goes into 5 and 5 once. So that's easy to simplify. I can do the same thing with the 4. 4 goes into 4 and 4 once. Then I could even say here that 3 times 2, which is what I see on the bottom, crosses off 6. So 3 and 2 cross off the 6. Or you could think about that 3 goes into 3 once and into 6 twice, and then 2 goes into 2 once and into 2 once that way. You could also put the 2 into the 8. There's lots of ways to do this. And as long as you are correct mathematically, you'll get the same answer. So the nice thing about what I've done now is I've basically crossed off everything except for that 8 and 7. So 8 times 7 is 56, which is my final answer. Let's do one more like this. All right, number 3 would be the permutation of 10 choose 2 over 2 factorial. Well, the permutation of 10 choose 2 is 10 times 9. 2 factorial is 2 times 1. So 2 goes into 2 once and into 10 5 times. And so that's the easiest way to simplify that. 5 times 9 is 45, which is my final answer. We're going to skip 4, 5, and 6 because I want us to do just a little bit more practice with some word problems now. So let's jump down to number 7. All right, number 7, you need to read 4 book reports for your English class. Your teacher gives the class a list of 7 books from which to choose. How many different groups of 4 books can you choose from the list? All right, so this is a combination because the order doesn't matter. It doesn't matter what order you read the books in, you just need a group of 4 books. So this is a combination of 7. Choose 4. You have 7 choices and you need to read 4 of them. So I'm going to take the permutation of 7 choose 4 over 4 factorial. So that would be 7 times 6 times 5 times 4, because again there's 4 spaces, so I multiply out 4 numbers. And then on the bottom I'm trying to divide out the repeats, so that would be 4 times 3 times 2 times 1. So I can do some cross simplifying here if I want. 4 goes into 4 once and into 4 once, and 3 and 2 both go into 6, so that's one way to tackle that. 7 times 5 would be 35 different groups. Let's do another one. A basketball league has 5 teams. 2 of the teams are chosen to play one another. How many different possible matchups are there? So again, this is a combination because if I say Team A is playing Team B, that's the same as Team B playing Team A. The order does not matter. So this is the combination of 5 choose 2. There's 5 teams and 2 spaces. So that's going to be the permutation of 5 choose 2 over 2 factorial. Well, the permutation of 5 choose 2 would be 5 times 4 over 2 times 1. I can simplify the 2 goes into 2 once and into the 4 2 times. And so my answer is 10 different matchups. All right, why don't you pause the video real quick and try number 9, then press play and check it, and that will be the end of our lesson. All right, so this one, you had 4 choices and 2 spaces, so check your work with mine. Your final answer here should be 6 different pairs of essay questions that you could choose. All right, so at this point now, you're going to go back to your How Many Ways worksheet that we worked on in the last lesson, and you are now going to solve every problem. You've already determined if they were a permutation or a combination, and now you're going to solve it using the shortcuts that we have learned today. Have a great day.